Welcome to this video. Have you ever wondered how to compare macroeconomic performance of different countries or track stock markets trends side by side? In this video, we dive into the financial data analysis. We fetch data from sources like World Bank and Yahoo Finance, clean and process it, and then bring it to life by powerful visualization. Whether you are a data passionate, financial analyst, or simply curious about how financial markets work, this video has something for you. By the end of this video, you will have a completed workflow for analysis of financial market performance and macroeconomy data. And also, you will have the Jupyter notebook to practice the provided code at home. So, what are you waiting for? Grab a cup of tea, settle in, and just get started. In this section, we are going to create two main components of our macroeconomy analysis, including the list of 12 countries in America, Europe, and Asia, and three main macroeconomy indicators, including GDP growth rate, inflation rate, and unemployment rate, to be incorporated in our next steps of analysis. So for countries, we create a list of countries using ISO code, which provide us with the unique identifier of different countries, which can be used in the APIs like World Bank API to fetch data. And as you can see, we use US for USA. So I put a comment to highlight it, and we can have a CA Canada, and BR for Brazil. So for saving time, I pause the video and complete this list. And you can easily add the other countries in your list, and then we will continue this file. Here we go. Our list is complete. So we can create the dictionary of indicators. In this dictionary, I use three main indicators of GDP growth rate, inflation, and unemployment as a main indicators for gauging the economic health. The advantage of this dictionary is that we can use it to map the indicators applicable in World Bank API to the human readable description. So we can have our code clear and understandable for other people. So the first indicator is GDP. So the description is GDP growth rate in percentage. and then we have the inflation rate based on the CPI. So again, we have and lastly, we need to include the unemployment rate. So again, we have the API code. Sorry. Okay, we used the most important indicators for this file, but if you read the World Bank API documentation, definitely you can find the bunch of other applicable indicators to be included in your analysis. We have a list of indicators and countries. You can easily add the other the parameters into the list. And also, if you are interested in analyzing other countries and indicators, it's great to share with me in the comment below. And in the next step, we are going to use these two lists to fetch data for the countries and macroeconomic indicators that we are interested in. In this section, we are using list of countries and indicators to fetch the data from World Bank library dynamically. First step in this section is importing WB data library to be able to fetch the data. And so we use import WB data. And then we need to create a function to fetch the data in a clear and dynamic mode. We call the function fetch World Bank data. And use list of countries and indicators aligned with the start and end date to be able to fetch data related to the countries, indicators, and through the period of time that we aimed. So easily we add countries, indicators, and then we can define a start and end year as a default. I consider the start year 2010, and for the end year Let's have 2023. Okay. So after that, we need to define the data. So here we use WB data.get data frame to directly fetch data from a World Bank library and save it in the data variable. So as you can see, we need to pass list of indicators, countries, and date to limit the data to the time that we aim to. And then we complete this part. By now we can have the data variable, but after having that, we need to reset the index to change it to the standard data frame columns. So we have data dot reset underline index and put in place equal to true for apply this change into the original data frame. And then it's good to rename the date and the country columns for more clarity and being more precise with the naming. Okay. So here we use the dictionary, and we need to have the old and new name. The old name is a date with the small t, and then we want to change it to the date with the capital D. And then again we need to have a country with a small c to replace with the country with the capital C. And again, we put in place equal to true to apply this change to the original the data frame. And finally, we return the data to finish our function. So as soon as we define the function, we need to call it and the fetch the data for countries and indicators as the date is in a default. We call this data set macro data. We need just add countries and indicator. And for making sure that our data is fetched correctly, we can use tail method. For example, we can have a last 14 rows to make sure that the data is up to date. So firstly, we need to run the preview section to create the list of countries and indicators. Here we go, and then the current section. Oops, seems that something went wrong. So let's check it. Okay, so yeah, I made the spelling mistake. So yes, countries, the U. So let's correct the mistakes, and yeah, yeah. Sorry for mistake, but as you know, the syntax error is a part and parcel of creating the code. So if you made such a mistakes, don't worry at all. You can easily trace your errors and fix them effortlessly. So let's run it again. Okay. So as you can see, we have last 14 rows, and we can validate that the data is accurate and in place. We can have a modular approach in creating our code, and in the future we can easily update and modify this function if we need to add more parameters or variables here. Okay, and if you are interested in having the data for other countries and indicators, feel free to add into your list or let me know in the comments below. In this section, we are going to implement the code for fetching stock market data using Yahoo Finance. And this section include 4 steps. Firstly, we need to import the required libraries like Yahoo Finance and Pandas, and then we are going to create a list of indices for 12 countries to be able to fetch the data dynamically. Then we create the function for implementing the required methods in Yahoo Finance library. And finally, we loop over countries and stock market indices to fetch the data and consolidate. To start, we need to import the Pandas and Yahoo Finance library, as we need these 2 libraries here. We use PD as pandas for data processing, and we need Yahoo Finance for fetching the stock market data. There we go. So okay, let's create the stock indices. Here we map the countries and stock market indices. For example, for USA, we have a S&P 500. So here we need USA as a key, map to GSP TSE, which represent S&P 500. And then we need to have another stock indices. The next one is indices for Canada. So for Canada, we have a TSX composite, which represented by GSP TSE. Okay, so Canada as the key, and the code for TSX composite is hash GSPTSE. We can add other indices to finalize this dictionary. Okay, we are done with the list of indices. So the next step is creating a function for manipulating the data and fetching the stock market prices using Yahoo Finance. So here we create a function that called fetch stock data, and we need 3 inputs here. The first one is the ticker, the second one is start date, and the last one is end date. And like what we have done before, we can define the date as a default here. So for a start day, I consider the 1st of January 2010 in a string. So and for end date, let's have the 30th of December 2023. As you remember, for macroeconomic data, we had this time interval. So we need to have the same dates here to be able to use the data together. Okay, so inside this function, firstly, we need to use the Yahoo Finance download method to fetch the stock market data, and we save the data on the data variable. So we have yf dot load, and it requires ticker, a start date, and end date. So and also we need to give the interval parameter if we interested in the intervals other than the D1, because the D1 is a default. So if we want, for example, data on monthly basis, we need to have a 1 when we fetch the stock market data, it always comes in open, high, low, and close. However, here we just interested in the close data for visualize it. So we need to manipulate the stock market data here. I consider another variable to just have the close column. So here I assign the close column, and additionally we need to rename the close price to the ticker, for having the clarity, because we are interested in stock markets of different countries. So here I columns and replace the old value with a new value. The old value is close, and the new one is the ticker. Finally, we reset the index for having more tidy data. So here I have the function. So here I use the reset index method. I close this function by returning the final stocks indexes. Oops. Okay. Once we finish defining the function, we need to loop over the stock market indices and countries to consolidate data in a one data frame. So here at first we need to define a dictionary to collect each market data individually, and then we can concatenate them into the single data frame. There we go. So here we call the defined function inside the loop to collect data for each country. We use country key and then put it equal to the function. Okay, we are done here, and then we need to concatenate the data. So we define a new variable called stock data combined, and then we use the concat method of pandas. And we put axis equal to 1 to consolidate the single data frames using the columns, so we can consolidate data appropriately. And after that, still we need to have some data manipulation to rename the columns. Okay, that's done. And we use the head method to validate the first 10 rows of the final data frame and check if the fetch data match our expectation. Now our codes are done and dusted. So let's to run this section. Oops, we have some syntax error. So it should be here. Yes, we had a spelling error. So let's try it again. Okay, so the start date is not defined. Okay, again we need to fix the bug here. Another error. So the list object has no attribute yet. Oh, as far as I'm concerned, it should works correctly. Oh, I got that. Here I forgot to use the column. Okay, let's run it one more time. Okay, it's done. So yeah, as you can see, sometimes we come across the syntax error. So using the Jupyter notebook and having the modular coding approach let you to fix the errors of each section or module separately, so you avoid accumulating too many errors. It helps you to develop and debug your codes swiftly. Okay, before jumping into the data visualization, we have a data cleaning and pre-processing to make sure that our data is tidy and ready to use for visualization. Like before, we create a function for keeping the modular approach. And then inside the function, we take several steps for pre-processing and cleaning the data. The function that we define here is clean pre-process. Okay, and it takes the data frame as input and produce the cleaned and tidy data set as an output. So inside the function, we first need to convert the date column into the date time format. So we need to create the date column equal to pd dot to date and time. So here we have the same column as an input, and then rewrite it but with another format. And here we set the errors as a CORs to convert any missing or inappropriate data into the not applicable, to be able to identify and remove such a records in the next step. So once we've converted the date into the datetime format, we can remove any not applicable value. Next, we need to sort the data into the ascending order to make sure that our data is in chronological order and appropriate for time series visualization. We use a sort value method. And use the date column as the reference column for sorting. Okay, so far so good. After that, we think about the possible infinite values, because when we have a data set, because of the calculation or other reasons, sometimes we might have an infinite value into the data set. So we need to take up the default step and eliminate any possible such a record. So next step is to replacing infinite records and change them into the not applicable values, because the NA values are easy to identify, and we can use the drop NA method to eliminate them from our data set. we use pd.na as the replaced values. Okay. Okay, it's good to go, but before finishing this function, I prefer to reset the index to make sure that the output data frame is tidy and neat. Okay, done. And we can return the data as a cleaned and preprocessed the output of this function. So as you can see, I took some default steps for cleansing the data. If you use other steps or manipulations, please share it in the comments below. I would love to know about your strategy for cleaning the data before visualization or other analysis. Once the function is completed, we can call it and save the preprocessed data on the new variable, which we call it cleaned macro data. That's it. Okay, now we need to run this section to check for any possible error or mismatching. So we got an error. It says that the module pandas has no attribute to daytime. Yeah, that's correct. I miss an underline, so let's run it. Okay, it is error free now. So now we have our data frame cleaned and ready to visualize for next step. After fetching macroeconomy and stock markets performance data and then cleansing the fetch data, now it's time to jump into the visualization to reveal the insight behind the data that we have previously provided. So in this section, I'm going to present you with two different style of data visualization. Firstly, I use the line graph for showcasing the macroeconomy data time series trends. And then I use the subplot to view and compare 12 stock markets performance side by side. But before starting our main codes, we need to import two critical libraries, including Matplotlib and Seaborns, to be able to visualize our data. So let's start by importing matplotlib.pyplot as PLT. And then we need to import Seaborns as a SNS. As we worked previously together, we use creating functions to have a modular approach in implementing our code. So here I define another function. I call it plot macro trends. This function takes the data, which is a data frame of macroeconomy variables, as an input, but it provides no data as an output. So here we don't have any return inside the function, but the real output would be the graph and the chart that this function can provide. And inside this function, we have three chunks of code for visualizing the GDP growth rate, inflation rate, and also unemployment data. But as these three codes are very similar, I talk you through the first part and invite you to pause the video and do two others as a practice and check if you can have a same code or different option for implementing these two parts. So let's start by adding plt dot figures this line is for determining the picture size. I usually find 12 in 6 as a good size for the picture frame. And then we need to have our line plot using the Seaborn. So this function is very easy to implement because you just need to add the data set, which equal to data as an input of our function. And then we need to determine the x and y variables. So here x is a time, and we put it equal to date column, which is available inside the input data frame. And we have the y, which is equal to GDP growth rate. As we expect that this line plot as we expect that this line plot provides the multiple line graphs for because it includes 12 countries GDP growth data. So we need to have the parameter for saying, okay, please specify each country by the specific color. So I put the country as a determinator. And finally, for having the more readable chart, I use marker. You can use any specific characters based on your preference, but here I use the small o. Okay, next we need to add some other element to our chart. For example, I use the title as a next element to highlight the suitable title for the chart. Let's say it GDP growth trends by country. As you can see, the most of parameters are self-explanatory, so I don't need to highlight every single characters and elements. However, if you feel you need the further description, you can check documentation, or let me know in comments below to provide the more description for next tutorials or video file that I provide for you. Then we have a X label. Like the X label, we need to have the Y. Additionally, we need to have the Y label. as we are going to have a different line for different GDP growth rates, so it's a good idea to add a legend as well to make it more readable for other people. Sorry. Also, when we have a very busy chart, it's good to have the grid on. It helps us to locate any point on the chart. So I put the plt.grid equal to true. And finally, another useful code is add a plt title layout to avoid any overlapping on the picture elements. And finally, we need to use plt.show to make the chart appear. Otherwise, we cannot have the chart on. So this is the first part. So here I pause the video and add two other parts, and I invite you to have those two other parts on your own and check your solution with me to see if we are using the same approach or the different approach. Okay, this part is done and dusted so far. So the last thing that we need to have in this so the last thing we need to complete this part is to call the plot macro trend function. So I use the copy paste to avoid any manual error. So here we need to call the data. As you can remember, we cleaned macro data in the previous section, so I can copy and put it here as input. Here we go. So we need to check the result. Okay, it is ready, and as you can see, we have the to a line chart for GDP growth rate, uh, and also we have another chart for inflation trends and unemployment. So you can see the different countries here. Some of them, some of them, some of them have the similar pattern, but some of them shows the different pattern in comparison with others. So let's move to the next part, to visualizing the stock market's performance data, and then we can conclude. As you may guess, we again start with defining a function. I call it the plot stock market subplots. Or we can simply call it plot stock markets. So don't need to make it too long, and we have a data as input. Okay, so in this part we need to have the figure and the axis elements equal to the subplot. And here we tell it to create a 3 in 4 grids to have a 12 independent subplots side by side. So we can easily compare them to each other and see what is the different patterns and what is the similar patterns. That's the philosophy behind these this kind of visualization. Otherwise, we could use the previous approach for visualization, but it cannot be as effective and visual as the subplots is. So I decided to have a subplot here. And as the x axis is allocated to time, we can share it among the charts that are vertically aligned. So I activate the share x. And below this, we flatten the axis for having the smoother iteration through the for loop when we want to look over the stock market's data and create a subplot. So here we have an axis equal to axis dot flatten. Don't worry if you find it a bit difficult or challenging. I will provide you with the fully commented Jupyter notebook, so you can download it and view or manipulate every single of codes, so you can have a more practice at home to make to be more comfortable with these provided code. Okay, so for looping our data, I need to create a list of the countries. So I use the data dot columns. If you remember when we were creating the data frame for stock market performance, we created we named the columns by the related countries. So here we can easily extract these lists by. So here we can easily extract that list by fetching the headline of the columns. And next, we just need to loop over the created list. We use enumerate to make it easy to loop over any single members of this list. So as you can see, we create the temporary list of country data equal to the columns related to that country inside the main data frame using .log. As we want to take all rows, and so we put here, and there we go. We have all rows for each country. So we are going to have the time series of the stock market performance on monthly basis here. And then use the Y indicator for saying that inside the loop we need to create the ith elements of subplots. We use country underline data dot index for having the index as the x variable, and then country data as the y variable. And label it by the country name. Then, like the previous section, we add other elements like the title and grids and so on. Okay, we put the grid equal to true. And also we add the legend. Located on the upper left, and use the font size equal to 10. Here we go. And let me think what else do we need. Okay, let's have a plt.title layout like before to avoid overlapping of the plots elements. Sorry. And also we add okay, we need to add our fig subtitle for adding the title for each element of subplots. So here, and here let's add the fig dot subplot, oh sorry, sub, and here let's add fig dot subtitle to add a title for the overall plot. So fig subtitle, and you can choose what you prefer for make it more distractive. And you can choose what you want to put as the subtitle to make it more descriptive. I pick a stock market performance by country. And choose a font size equal to 16. That's it. And never forget to add plt.show to have your plot visible. Okay, this function is finished, and we need to call to execute it. Okay, let me copy and paste exactly what I created here. And for data, we saved the stock market data on the data frame with the name of stock data combined. So we can use this as an input. When you are coding using when you are creating code using the modular approach, it's really looks like that you are creating the machines with the inputs and outputs. So in this sense, it can considered modular. So okay, we are done here, and we need to execute this section before moving forward. Okay, let's test it. Okay, let's test the provided code. Okay, it looks like we have a kind of error. So as you can see, we can understand that the some part of the loop worked correctly, because we have the first element of subplot here. So it seems that for I equal 1, it executed here, and then okay, we had the spelling mistake here. So the loop stopped here and it gave the error. So here we correct the rate to specify that we have the rectangle with these coordinations for putting our graph in the center of the layout. So let's run it again. Okay, you see we received no errors, but you can see that the first element is provided, but others created but not visualized here. So we can understand that this is not a, that kind of technical errors which interrupt the code, but we have had some other issues here. So if we pay attention, we can see that we needed to outdent this section because here we have a loop, and after that as soon as our loop is over, we need this code out of the loop for being executed for the all elements. So for your information, the Python is very indent sensitive language, so you need to be careful. Let's run it again. Here we go. We have the whole line charts, so you can compare the stock market's performance for any countries. For example, you can see you can compare the US with the Canada, Brazil, UK to see which one has performed better than others. That's it for today's video. We have covered everything from fetching data from Yahoo Finance and World Bank, cleaning data, and presented by powerful visualization. If you found this video helpful, please consider subscribing for more content, as I aim to teach from basic to advanced level of financial data analysis and strategy building. Also, feel free to share it with the other people who are interested in learning financial analysis and data visualization. And finally, don't forget to practice at home using a Jupyter notebook that I've linked in description below. I cannot wait to see you in the next video, and I hope you enjoy it.